Hello, hello. Welcome, everybody. Appreciate you guys being here. We're going to go ahead and wait an extra probably 1 to 2 minutes just to let stragglers hop in here. Probably just 1 minute. We'll just wait 1 minute. You guys hear me, see the screen, see the chat? Go ahead and get all those out of the way. All right, we got a thumbs up. All right, cool. Thanks, Paul. Thank you, thank you. Give it about 30 more seconds. We'll dive right in, guys. And the wonderful, I assure you, it's going to be a great webinar. Don't leave. Okay, go ahead and start, guys. Just want to welcome all of you to our Azure Stack webinar. Obviously, with the Broadcom VMware acquisition, there's been an uptick in the conversations that we're having around it, the questions that are being asked. We have our data center practice manager, Joe Galvan, and his Microsoft system engineer, Brad Owen, here to do a fairly technical deep dive into all things Azure Stack. We're going to be taking some questions throughout. If you have any, just leave them in the chat. And then at the end of the presentation, we'll answer any questions that you do have. So without any further delays, I'm going to go ahead and hand it over to Joe to kick us off.
Hello, everybody. Thank you for joining today. So since its inception, Azure Stack HCI has been of keen interest to those looking to extend their Azure presence onto their on-prem environment and extend that management experience. That interest is even greater today, with many looking at hypervisor options given the recent VMware changes, as Rowdy alluded to. We felt like this was a good opportunity to share our thoughts on Azure Stack HCI, with more and more folks expressing interest. So today we'll be doing an overview where we look at Azure Stack, what it is, what Microsoft's long-term aims are for the platform and their goals. We'll do a technical deep dive where we get into the nuts and bolts of how it works, how it's architected, and what the requirements are. And then we'll do a brief demo where you get a feel for how it looks from an interface, how it's managed, and what some of those features are. And then finally, at the end, we'll conclude with the questions and answers. So what is Azure Stack HCI? It's a hyper-converged platform where compute and storage are scaled out by adding nodes. Storage can also be scaled up by adding drives to those nodes. It's deployed on validated hardware. There's multiple hardware manufacturers that have validated solutions. You may already be familiar with some of the technologies that it's based on, such as Windows Server, Hyper-V, and Storage Spaces Direct. And one key point is it's managed and licensed through Azure. Common use cases include data center consolidation, virtual desktop infrastructure, and remote branch offices. Data center consolidation, we can kind of think of that as virtual server infrastructure, where perhaps there's concerns on the workloads having low latency and high throughput and having the data locality, or maybe it's governed by compliance where that data needs to reside within a particular region. Virtual desktop infrastructure is kind of an extension of Azure Virtual Desktop to your on-premises solution, in this case being Azure Stack HCI. Again, thinking back to latency and data locality, maybe you have something like a geologist doing oil and gas interpretations where they need their workstation to reside fairly closely to the data set that they're analyzing to not be bothered by latency and having trouble navigating their application. Remote branch offices lend themselves rather well to Azure Stack HCI. We can scale down to as low as a single node or 2 nodes if we want redundancy. And these can allow for those remote compute requirements of branch offices such as file print and Active Directory services. I think it's important to kind of look at the evolution of Azure Stack over time. So back in 2018, Windows Server 2019 was released, and it included Storage Spaces Direct, which is kind of Microsoft's software-based clustered shared storage, right? And that's really where a lot of this magic happens, as well as Hyper-V and cluster failover services, two existing services that were Hyper-V revolved around. This kind of represented Microsoft's first, on-premises HCI, right? Just in the form of Hyper-V without the Azure component. Fast forward to a year later in 2019, Microsoft announced Azure Stack HCI. And since then, it's evolved quite a bit. The first GA release back in 2020, the very first version was 2020 H2. And at the time, that supported Windows and Linux VMs as workloads. Since then, there's been 3 additional annual releases. Typically, they release around November timeframe annually. 2021 H2 brought the Azure Kubernetes service as far as the supported workload. In 2022 H2, that update really focused around feature improvements and then simplified deployment. There weren't any additional supported workloads, but they also broadened the hardware vendor support list. 2023 H2 is when things really started to take shape. So it's a very different deployment model, different management model. Everything is done end-to-end cloud-based within Azure. Also with 23 H2, Microsoft introduced Azure Virtual Desktop as a supported workload. So as far as what types of hardware vendors support Azure Stack HCI, we recommend Dell, Cisco, and HPE. Obviously, they're good partners of ours, and we're familiar with their support and things like their management planes for updating firmware. There's also many, many more. You can look at this in the Azure Stack HCI catalog to determine which vendors are supported. There's 3 primary types of solutions. Really, it consists of premier solutions, integrated systems, and validated nodes. Premier solutions are really turnkey. All the software and hardware comes pre-configured based on design, and the services are included to deploy and integrate into your environment as well as your Azure tenant. Integrated systems come with OS, hardware, firmware, and drivers loaded, essentially ready for some quick node configuration, things like IP, etc., and then quickly to cluster configuration and creation. You could think of this as a middle ground between Premier and Validated. Validated nodes, customer installs and configures the OS or with your trusted partner in the cluster, and they're also responsible for firmware management. So the validated nodes offer the broadest selection of hardware, but they're kind of a build it on your own type of approach. And now I'll move on, Mr. Brad.
Yes, sir. So some of the key features and benefits of the Azure Stack HCI platform, right? We have built-in security and compliance. We'll talk about it a little bit more in some future slides, but there are a lot of things that we enable by default, which are often left behind on other clusters. So we have built-in security and compliance. We simplify management by using intuitive tools and features that make it easier to monitor and manage your infrastructure. We have hybrid cloud integration, which allows you to easily extend your on-premise infrastructure to the cloud and sort of manage it from there and have some visibility into what is happening on your on-premise in the cloud as well. And then it, of course, offers high performance and scalability. HCI helps deliver high performance and scalability to meet the demands of your organization's growing infrastructure needs, which we'll dive into in some future slides here. So what do you need in order to start an Azure Stack HCI cluster? It's pretty simple. The list isn't that long. We start out, of course, with the validated nodes that Joe was talking about. We have to make sure that we have all the necessary components, parts, and pieces in order to build this cluster. There are some certain requirements which we'll dive into. Thankfully, you don't have to worry about those requirements too much because we have a list of validated and known to work hardware models. We also require an Azure subscription with permissions to deploy resources to the subscription. Operating system licenses for your workload VMs, for example, Windows Server, Red Hat, Making sure those are licensed appropriately is important, of course. We also require an RDMA capable switch with at least 10 gigabit Ethernet or faster links. It's actually not a requirement, but it's highly recommended. We'll get into that a little bit more in a future slide. And also, we require an internet connection. This isn't always on cluster. It checks in with Azure every 30 days. If in the event it doesn't check in within 30 days, all your workloads continue to still run. However, you're no longer able to deploy new VMs or create new VMs on the Azure Stack cluster. And then finally, an OU to store computer objects. If you're familiar with Active Directory, you know why this is needed, right? In order to join our computers to the domain, we need a place to land them. So that would be the OU. The minimum server requirements, because you're buying a certified solution, you really don't have to worry about these requirements, but we went ahead and listed in them here just so we could talk to them real fast. So the number of servers which are required are 1 to 16 servers are supported per cluster. Each server must be the same model, manufacturer, have the same network adapters, and the same number and type of storage drives. The CPU needs to be a 64-bit Intel Nelhem grade CPU or AMD EPYC with SLAT translation enabled. It requires a minimum of 32 gigabytes per node of RAM. We require at least 2 RDMA network adapters, which are listed in the Windows Server catalog. For the BIOS, Intel VT or AMD V must be turned on. The boot drives, a minimum size of 200 gigabytes per drive. The data drives, we require at least 2 disks with a minimum capacity of 500 gigs. These could be NVMe, SSD, or hard drives, spinning hard drives. Single server clusters, a little note with that is single server clusters can only use one single drive type, NVMe or solid state drives. Of course, if you've used Windows 11 or any of the newer editions of Windows Server, it requires a TPM module to ensure that we can turn on those advanced security features. And then finally, it needs to support secure boot. So let's talk about the architecture of Azure Stack. What actually makes up a cluster? What technologies are coming together in order to give us this hyper-converged experience? The first one and foremost is going to be the operating system, right? Azure Stack HCI OS is a specialized operating system designed specifically for hyper-converged infrastructure. It's actually based on the Windows Server you know and love, but it runs Windows Server Core, and it has some extra tailored features which enable some of the enhanced HCI components, which we'll talk about in some upcoming slides. Furthermore, it's Hyper-V, right? Hyper-V is the key component of Azure Stack architecture. It provides the virtualized environment for running multiple operating systems on a single hardware host. We also utilize failover cluster manager. Failover clustering and Azure Stack HCI, it helps provide high availability and resilience by automatically shifting workloads to functioning nodes during hardware failures, ensuring minimal downtime. Storage Spaces Direct is our hyper-converged storage technology, which enables us to take all the local drives from the various nodes in the cluster and then pool them together and make them available to other nodes so that in the event one node goes offline, we can ensure that those workloads and systems are still being kept available and continually accessible for whatever services you're providing to your customer. We also have hybrid cloud connectivity. A big piece of Azure Stack is kind of bridging that gap between what your on-premise workloads are and the cloud. There are some capability differences between 22H2 and 23H2, but the idea there is that we start to bridge that gap and make it more of a seamless experience. And then finally, as I alluded to, we have built-in security. Azure Stack HCI provides the built-in security features that help you protect your workloads against cyber threats and unauthorized access. So we'll go ahead and start hopping right into some of the components and get a little bit more detail on what they do. First, we'll start with Storage Spaces Direct, right? What is Storage Spaces Direct? It is a software-defined storage solution that will pool the local storage of each server in an Azure Stack HCI cluster. Some of the key components which make up Storage Spaces Direct are going to be the local storage. These are going to be your physical drives in each node including your SSDs, NVMEs, hard drives that store all your data. On top of that, we layer a software storage bus, and that enables the storage to act as a virtual network, connecting and managing all the physical drives in the cluster seamlessly. We have another layer, the storage pool. This is where we actually combine the drives into a singular pool and make them available to all nodes in the cluster. We add a cache layer to help accelerate read-write performance, right? To field those initial I/O requests and then pass them off to slower tiers, which we may have, high-capacity drives, slower drives. And then we add the resilient file system on top of it. This is an optimized file system, and it helps provide high performance while acting as a reliable file system with checksums and all sorts of checks, which help ensure that your data isn't being manipulated or changed, or it's maintaining the security and the completeness of that data, right? We're always checking to make sure that we're not losing anything and it stays accessible. We also add cluster shared volumes, which offer a unified storage volume across the entire cluster. This helps simplify the data access. And then finally, on top of that, we add storage spaces. And this is where you store your virtual hard drives with redundancy, ensuring it's always protected and available. Some of the networking in Azure Stack HCI, the ideas here are that we're always simplifying the network infrastructure, right? We want to make sure that we're keeping it simple. That way, when something goes awry, or if anything goes awry, we understand and have a clear path onto resolving that as quickly as possible. So we always work to consolidate difficult operations and network setup in Azure Stack HCI. And like I said, that allows our admins to create and deploy network intents. Network intents allow you to group traffic according to its purpose and function. We have software-defined storage, software-defined networking capabilities. These are going to be kind of like an equivalent would be like a vSwitch, right? Internal switching infrastructure, which never leaves the cluster, but allows you to help design and configure a virtual network that is secure, scalable, and resilient. And then finally, we make sure that we're scalable, right? Azure Stack HCI will help provide tools and features that will enable you to scale your network infrastructure needs based upon your business needs. You can add remove nodes to your network infrastructure without disrupting your business operations. There's no downtime for adding nodes or removing them. So diving in a little bit more into network intents. What is a network intent? An intent is a definition of how you intend to use the physical adapters in your system. Essentially, an intent has a friendly name, identifies one or more physical adapters, and includes one or more intent types. What are those intent types? They're going to be management, compute, and storage. Your management intent is going to be used for management access to the nodes. Think like your OS itself. This is the intent that your OS will ride. The compute intent is where your virtual machine traffic will live. And then finally, your storage intent. This is used for SMB traffic. Storage Spaces Direct highly utilizes it to ensure that everything is kept up and running and highly performant. This picture over here is kind of trying to show how different NICs can be grouped to different intents, but you don't necessarily have to do that this way. You have the option to separate management and storage and compute traffic, but if you want, you can technically group all of that into one intent, which includes the management, compute, and storage. So we'll talk more about the network topology, right? This is there's three main network topologies which we recommend investigating which one's right for your business. The first is going to be our fully converged switch storage. And what this is showing is that we have one set of physical adapters here. And on this set of physical adapters, we have redundancy to the top of rack switches. So one adapter goes to the first top of rack switch, the second adapter goes to the second. That way we ensure that if we are to lose a top of the rack switch, we always have at least one viable path still available. And again, what this is showing is all of our intents are stored within this one set of adapters. It's a coalesced intent group, which allows you to just simplify your network so you're running the least amount of cables possible and also enabling that high resiliency that we were talking about. So the second the second network topology is non-converged switch storage. And what we're seeing here is a set of adapters. These set of adapters have the compute and the management intent on them. And then a second set of adapters, which is actually fielding the storage traffic. This would be like, for example, if you were high IO workloads, or maybe you don't necessarily want your storage traffic running over the same network that your management or your compute intent is serving. This is a great way to help separate that out and ensure that that stuff stays separate, since storage traffic tends to be very chatty. And then finally, we have switch list storage. And what this is showing is an intent, a set of adapters with a compute and a management intent. And then below on this image, we actually have interconnected RDMA interconnected NICs, which run directly to the other nodes. The benefit of this is that you don't require an RDMA capable switch. You don't need to necessarily have 10 gigabit Ethernet or higher on your top of the rack switch, although that is going to be recommended either way. Some disadvantages of this, right? There's quite a few. But we find that, switchless setups, they're going to offer the lowest level of resiliency, and they're going to require a lot more additional planning. If you intend on expanding out beyond 2 nodes, or if your capacity needs grow, you don't really want to utilize this scenario, because the more adapters you add and the more nodes and the more hosts you add, typically what we find is that you're going to eventually, for these network adapters, you're going to end up exceeding the cost of the switch itself just to create a fully converged switch storage or a non-converged switch storage topology. So switchless is capable, but it's best served in remote offices or where your capacity needs aren't expected to grow or change. Azure Stack offers a wide array of security and compliance. Right, we start with data encryption. Azure Stack helps offer robust data encryption that protects your sensitive data, which includes full disk encryption, BitLocker drive encryption, and data at rest encryption. We have something which is called secured core. Secured core capabilities in Azure Stack HCI are advanced security features designed to protect against firmware level attacks and ensure system integrity, providing a highly secure platform by default to minimize vulnerabilities and enhance protection against sophisticated threats. I want to stress that default is there because when we're setting up an Azure Stack cluster, the secured core becomes essentially a checkbox. In other platforms, typically you'd have to go back after you deploy the system and try to toggle some of these things on and turn them on, and you have to make sure that you have a checklist to do those things. Not in Azure Stack. By default, when you're deploying this thing, it's a checkbox. And we can ensure that we can meet those requirements simply because, again, we have those validated nodes which have the capabilities to enable secured core. We also support network isolation. As we talked about with the storage-defined networking, we have the ability to run workloads in virtual networks, which helps protect the network infrastructure with network segmentation, virtual firewalls, and private network connections. Azure Stack HCI has several compliance certifications. Not to get too into the weeds, but we have the Common Criteria for Information Technology, or the CC. We have the IEC, or International Organization for Standardization, PCI certification, or Payment Card Industry certification, DSS, or Data Security Standards, HIPAA standards, and finally, the FIPS 140 is in process right now for the 22H2 edition of Azure Stack HCI. So to dive more into the secured core components, right, these are these default settings which we have right out of the gate, and they really operate on 3 pillars of security, right? The first is ensuring our hardware is trusted, and we do that by creating a hardware-based root of trust, utilizing the trusted platform module, the TPM module, which it comes included in the validated nodes, and kernel direct, and we also protect using kernel direct memory access protection. The DMA protection helps protect against external peripherals from gaining unauthorized access to memory. So for example, if a malicious actor or threat actor is to gain physical access to your cluster, they can't go and plug in a USB drive, which would allow them to start to infiltrate or compromise those systems. The second pillar we have is we defend against firmware level attacks. And the ways that we do that are through the UEFI secure boot. Again, if you're familiar with Windows 11, the requirement to enable UEFI secure boot ensures that only signed and trusted software is loaded during the boot process. We offer firmware protection to help monitor and secure firmware updates, and we ensure that only verified and trusted firmware is allowed. And we also implement System Guard, which helps protect and maintain the integrity of the system as it starts up. Our third pillar is preventing the execution of unverified code. And we do that using virtualization-based security, which helps isolate critical security functions from the operating system, right? So that if a VM is compromised, we ensure that the host also can't be compromised. We implement credential guard, which helps isolate and protect the credentials within a secure container. So some of the ways that we manage Azure Stack HCI, right? I've alluded to it a few times, but this is built on the Windows Server OS, which means that many of the tools that we utilize today to help manage our Windows environment are also compatible here. Today, we'll be touching on a few of them, specifically the Windows Admin Center, SCVMM, and PowerShell. But so what is the Windows Admin Center? The Windows Admin Center is a web-based management tool which provides real-time performance monitoring and integrated services. SCVMM is essentially System Center Virtual Machine Manager, and it is a unified management interface, resource optimization platform, and it helps provide comprehensive network and storage management. Typically, we find that backup products will utilize SCVMM. If you think back to vCenter 5.0 days when we had like the physical application, that's kind of an equivalent of what SCVMM is. Only SCVMM has the ability to help manage your VMware environments as well. SCVMM again is leveraged by third-party tools such as backup and replication. Those third-party tools need to be aware of the cluster and the VMs which reside on that cluster and how those VMs are moving on different nodes on that cluster. So we typically see SCVMM utilized in that scenario. Azure Arc helps provide hybrid management solution. It helps bridge the gap between your on-premise infrastructure and the cloud by providing hybrid management solution with security and compliance and scalability, right? Ensuring those settings are being set once and can help be applied in a wide array of systems, and ensuring compliance with that, right? And then finally, my favorite, PowerShell. This is our command line interface. It provides automation and scripting and detailed resource management. I don't need to go too deep into that one. If you've used Windows, you probably are familiar with what PowerShell is. To go back to the Azure Arc, we could talk about integration with Azure services. So what is Arc? Arc is a hybrid management solution that allows you to manage your HCI cluster from the Azure portal. It provides centralized control, policy enforcement, and compliance management across both on-premise and cloud environments. It's simply an agent which runs on your machines. And that can help provide Azure Backup, which is the cloud-based backup solution that can be integrated with Azure Stack HCI. And this will help you provide offsite backup and disaster recovery for your on-premise infrastructure. We also offer Azure Site Recovery. So Site Recovery is a disaster recovery solution, which can be integrated with Azure Stack HCI, and it provides site-to-site replication and failover for your on-premise infrastructure. Last but not least, we also utilize the Azure Monitor, which is a cloud-based monitoring solution. It's great for storing analytics and performance data of the on-premise infrastructure. Can help unify some of those interfaces so that you can pull in multiple performance metrics and kind of start to determine where your bottlenecks may lie, right? Azure Stack offers performance, resilience, and scalability. We very much support high IO workloads. You've heard me mention it a few times. The validated nodes, they come using established standards, high performance cache for storage, 10 gigabit or more networking. We also support scale up and scale out capabilities. Azure Stack provides scale out capabilities, allowing enterprises to easily and seamlessly expand their infrastructure per business needs. In the event you need to scale up or scale out, it's as simple as adding disk or adding additional nodes, which is a very simple process in Azure Stack HCI, which I'll talk about a little bit more in a second. And then finally, we also offer a high level of resilience because this is a hyper-converged infrastructure. Ensuring that there's no one single point of failure actually can happen by default in Azure Stack HCI. So a lot of those technologies we talked about already with Storage Spaces Direct can automatically be handled by Storage Spaces Direct. So we're not having to get into the nitty-gritty configuration of each of those services. We can if we want, but Storage Spaces Direct can also handle that for us. So we'll dive into each one of these a little bit more right now. We'll start with the performance. As I've alluded to multiple times, the cache layer, right? We can have a mix or a tiering set of drives, NVMe, SSD, and HDDs. Again, we don't necessarily need to configure those on our own. Storage Spaces Direct can automatically determine the speed and performance of those drives and automatically tier them for us. And then using the fastest drives, it'll provide a cache layer to help field the initial I/O workloads which come into it. We also support dynamic resource allocation. So think about this as like your DRS, but for Azure Stack HCI. So if one node in particular is running hot, maybe it's oversubscribed on CPU, Azure Stack HCI can automatically evaluate the performance of the other nodes and the demands taking up resources on the other nodes. And if it finds a suitable host to land those resources, it can automatically move those VMs to those hosts. Right. It doesn't like to do that super aggressively, but you can configure the aggressiveness with a slider in the interface. If that's not enough, we also offer the ability to support NVMe storage devices. So if you find that you're being capacity or I/O bound, right, we have the fastest drives which are available out there. And we can do full clusters based on NVMe storage drives. And then finally, because again, we're using validated hardware, we ensure that we're always having the most seamless integration between the hardware and the software itself. On the left side, what we're seeing here is a bit of performance monitor in the Windows Admin Center. So if you're familiar with Windows Performance Monitor on Windows itself, this operates very much the same as you're accustomed to today, right? At the top, we select the servers which we want to view information for. We select the object which we want to view performance metric for. We select the instance and then the counter. And then finally, the graph type. We can do table or line graph. And then it plots it out real time in front of you for you to be able to, decipher, determine, hey, here's where my bottleneck may lie, or maybe we're not putting enough, maybe not enough spindles, not enough disk. It depends. Whatever you're trying to solve or research. We talked about scaling a little bit. So there's two main ways that we like to scale: adding servers and adding drives. Adding servers is a very simple process. When you're in the Windows Admin Center, you simply go to the Servers tab, hit Add. You ensure that the OS is deployed and it has a valid IP address on your network, and that the Windows Admin Center can see it. Once you do that, you say, hey, I want to go ahead and bring this into the cluster, and the Windows Admin Center will go out to that server, install all the necessary roles and features, and then pull it into the cluster and automatically rebalance with the other resources that are available already. We can also add drives. It's not a hard process. By default, it comes with the ability to hot add drives. So as soon as you plug a drive into a server, it starts looking for some symmetry in the other servers, and you can plug those drives in and they'll automatically be ingested into the pool as well. Again, we offer the very flexible for various types of drives, including the NVMe, SSD, and HDDs. Just depending on your performance and capacity needs, we have the ability to choose and mix and match whichever makes the most sense. There is a limitation on scaling, as mentioned in some of the minimum server requirements. There's a maximum of 16 nodes per cluster. So if you're exceeding that, you're looking at adding another cluster or enabling some sort of rack failure tolerance. This picture on the left-hand side, what it's showing is NVMe drives automatically being scaled. So these are going to be your cache drives, and we're showing that we're adding 2 additional drives initially, which this is an automatic procedure that it will automatically determine, hey, if I have 2 cache drives and maybe 4 drives, then those 2 cache drives are supporting 2 drives each. Or as you can see, as you add more drives, it can automatically scale and make sure that it's running in parallel and also very what's the word I'm looking for? It can also run very symmetrically, right? Symmetry is a big part of how these things run, ensuring that not one NVMe cache drive is being oversaturated with reads and writes. This sort of dynamic scaling helps us ensure that we don't have to worry about managing that and assigning those things ourselves. Storage Spaces Direct can automatically take care of that and help us determine whatever the best configuration is there. Finally, we can talk about resilience. 2 of the ways that we provide resilience, again, this is all, you can have it automatically managed through Storage Spaces Direct, but we support mirroring and parity. There's 2 main types of mirroring, 2-way mirroring and 3-way mirroring. All right, 2-way mirror is going to basically put the data in 2 different places, and that's going to help us tolerate at least 1 failure up to 1 node. If we have a 3-way mirror, we're writing that data in 3 different places. So with that, we can always ensure that we always have, we can tolerate 2 hardware failures. We also have parity. There's single parity, which is similar to RAID 5. It tolerates 1 failure, and then dual parity, which tolerates 2 failures, and we gain up to 80% efficiency. Again, all this stuff is managed automatically by Storage Spaces Direct, but in the event you find that it's not doing exactly what you want, or maybe you want more capacity, those settings can be manually changed. On the left-hand side, we have some fault tolerance examples of a 4-node cluster. You can see for yourself, we can lose up to 2 whole nodes. If we are to lose 2 whole nodes, say for example, there was some data on server 3 and then there was some data on server 2, because we are running in a 3-way mirror, we can ensure that that data is still stored somewhere else. That helps ensure that all our data remains safe and continually accessible. In the event you lose a drive, the HCI cluster will attempt to recreate, or it'll self-heal and actually write that data from other parts in the cluster to ensure that it can tolerate another failure, and that we're always maintaining at least 3 copies of that data. Until, of course, you plug the new drive in, and then it can reallocate those bits and bytes to the appropriate storage device and help rebalance it. On the bottom right, what we're seeing here is a cache drive failure. So when a cache drive fails, any writes which have not yet been destaged are going to be lost to the local server, meaning they're only going to exist on other copies in other servers. So we're not necessarily losing data because we're storing copies of that data in other cache drives as well until those copies are offloaded, right? Until we have verification that those bits and bytes have been written to our capacity storage. So if we lose a cache drive, just like any other drive failure, storage spaces will automatically recover by consulting the surviving copies. For a brief period, though, the capacity drives which were bound to the lost cache drive will appear unhealthy. But once the cache rebinding has occurred, which is automatic, and the data repair has completed, which again is automatic, they will resume showing as healthy. This scenario is why at a minimum 2 cache drives are recommended and required per server to preserve performance. So best practices for implementation, right? It all starts with the hardware selection. Ensuring that we have the right hardware is as simple as ensuring that it's on the validated hardware list. That part's pretty easy. Our network design is, I'm a fan of keeping network design as simple as possible, and Azure Stack really makes that easy to do. by just with the use of network intents, as we talked about. Our storage configuration, while we can get into the nitty-gritty, of course, configuring storage is going to be critical for the successful implementation of Azure Stack. We just need to make sure that we're getting the right disk for it and have the right amount of capacity growth projected. And then finally, always reviewing the documentation. As with all Azure services, the only constant seems to be change, right? I think we've all seen that with Azure AD becoming Entra, and then every time we log into the interface, we have a new UI or a new product or preview feature that we can start to play around with. So Azure Stack HCI, it's a rapidly changing product. So ensuring that you always keep up with the latest information available is crucial to implementation success. For monitoring and troubleshooting, I touched on this a little bit before. You can monitor using the Windows Admin Center. So Azure Stack HCI provides the monitoring of infrastructure components, including the servers, the storage, and networking equipment. It's consistent with existing methods because we are running that Windows Server OS. All the tools and methods which you currently utilize today to troubleshoot performance issues or any sort of issue for that matter on Windows Server, it will most likely work on Azure Stack HCI as well. Think things like Event Viewer, Performance Monitor, the sysinternal suite, etc. And also we offer advanced telemetry and diagnostics. Azure Stack HCI includes comprehensive telemetry and diagnostics capabilities that collect and analyze data on system performance and health. These tools provide insights into the infrastructure by enabling proactive maintenance and troubleshooting, helping to resolve and identify issues before they impact operations. There's actually an extension in Azure Stack HCI, which is basically a one-click log gathering coalescer, and that file can be used then to do sort of a remote help with Microsoft support to help them get a preliminary view of whatever issue you may be encountering or need assistance with. So future roadmap and innovations, obviously we suspect that there will be continued rollouts of new hardware. So Azure Stack will continue to support the new hardware where it can be verified and validated. So that's going to just continue to provide greater flexibility and compatibility with modern hardware platforms. We expect there will be a lot of new features introduced, right? Improved security, data protection, performance. All of it's going to be released to enhance the user experience and productivity. And then finally, we're going to also expect many new integrations with Azure services, right? As these solutions continue to be built out, the idea or the goal starts to become managing your Azure Stack HCI infrastructure the same way you would manage your Azure infrastructure, right? So instead, what it starts to become, instead of deploying to your Azure Stack, you start deploying to regions, which will become your Azure Stack. And that'll just help unify that experience and make it more seamless. I won't say it's completely there today for that, but that is definitely kind of the vision, I feel, of Azure Stack HCI is to help unify the way you do things. So we talked a good amount about Azure Stack itself, and now I'm going to kind of go through a short little demo. This is going to be just running through the Windows Admin Center interface and SCVMM so you can get kind of an idea of what the Azure Stack looks like and then some of the capabilities that are there as well. So what you'll see here now is our system, our host PDS10AZHCI01. What this is it is our Azure Stack host, right? This is going to be what you initially see when you first install the OS on the system. It's a little daunting for people who don't really like the command line, but it's a lot easier than it looks, trust me. Here, this is the sconfig interface. So if you've ever logged into a Windows server before and you've never seen sconfig, open up a command prompt or a PowerShell prompt, type the word sconfig, and this is what you'll get. This is a really helpful interface because most people don't like joining to the domain or changing network settings using PowerShell. You can do all that stuff right here, right? So changing the domain, the work group, the computer name, adding local administrators, enabling remote management, remote desktop, network settings, changing the date and time. Here's what the network settings look like. All that stuff can be done here. And as I mentioned, right, we are just running a flavor of Windows Server. So if the things that we don't want aren't readily available to us in sconfig, we can just drop simply down to PowerShell, where we can run all our favorite commands that we know and love. Things like get child item, get disk. This is actually showing cluster shared volumes, right? So these are volumes which are available to every server in the cluster. It shows some of our SATA DOMs. It actually shows one of the USBs I use to image. You can also run get net adapters, and this will show us our network adapters. So you can see that the network adapters we talked about, the Mellanox in this case, are RDMA capable. And it also even shows our intents as well right there. So things all our traffic is grouped onto these two Mellanox adapters. We have an intent running the compute, management, and storage on those two adapters, and it works well. So that is the Azure Stack OS, if you will. Now I'm going to kind of shift over to what the Windows Admin Center is. For those of you who aren't familiar with what Windows Admin Center is, it is a free tool offered by Microsoft. It started out a little lackluster in my opinion, but it's really come quite a long way since its inception, and it's probably one of the primary ways you're going to want to manage Azure Stack. So here I have a system PDS10 AZ HOU 22 specifying the version we're on, 22H2. And if we click into it, you can see it goes out, it connects to the cluster, and it pulls data from that cluster. So we're not really storing any sort of cluster data on this system as well. And because we are running a lab environment, we've been pretty aggressive with it. We've done things which has caused the cluster validation to find some problems, which is normal in this case. And as we mentioned before, the Windows Admin Center, it's tightly integrated with Azure, right? So what you can actually do in the Windows Admin Center, which is pretty cool, is there's a checkbox you can check which requires you to sign in with your Entra ID. And that's awesome because then you're funneling people through your conditional access policies, right? But this is cool because it shows, right, this is our dashboard, the initial page we get. So have the alerts at the top. That's going to be concerning. Those are the things that we want to see at the top. We also see that we've been connected to the HCI or the registration. So we have items in Azure now, which are representative of our cluster. We have Arc-enabled servers, meaning we're running the agent so that there are certain components and features which we can help manage through the Azure Azure portal. And then also the Azure resource itself. You can see that we have all servers healthy, all drives are healthy. You can see we're running a total of a whopping total of 2 virtual machines right now. All our volumes are showing healthy. We have CPU usage, memory usage, storage usage, and then also some of that real-time cluster performance that we were talking about a second ago. Similar to as if you were to log into Server Manager and you were to say, hey, start the performance counters, this kind of always running, so you're able to see it. To dive into some of the settings, I'll briefly touch on these. I'm not going to go through each individual one, but we have the in-memory cache, which is configurable. We can use memory in the servers to cache frequent reads. This is very helpful when you're doing virtual desktop, right? You don't necessarily want to have to read the base level OS from the spinning disk every single time it's referenced. So we can actually onload that into the memory so that we are getting the highest performance of reads from that. Storage spaces and pools. This goes over just kind of the key fundamentals of what our storage spaces are configured as. You can see that we have repair speeds in here, retire failed drives, always add new drives. All that is available. We can configure the cache, disable if the last node. We can configure node shutdown behavior so that if a node's shut down, we can automatically move VMs to other nodes in the cluster. Cluster traffic encryption is in here. We have a witness because this is a 2-node cluster of witnesses recommended. Our witness actually runs in Azure storage accounts. So in the event one node goes down and it's not able to see the other node, it can consult the witness to say, hey, I'm not able to see the other node. Am I okay to take over as the kind of the failover cluster leader? That's how we do the witness. You can also use things like local file shares, but I like the Azure portal. I like having the witness out there as well. Affinity rules, we can use these to ensure that we bind our certain hosts to certain VMs or certain VMs to certain hosts. Say, for example, you're a domain controller. You don't want both domain controllers running on one single system in the event it goes down. It makes sense to have your domain controllers at least spread across 2 different servers. We also configure live migration in here, enhanced session mode, which is basically a way of consoling into the VMs which are running. And here you can also see we have monitoring data settings, resource bridge. We can do a service health check of the system. We can also activate Windows servers directly through Azure Stack HCI, which is kind of cool. So if you want, you can actually have your Windows servers be activated through Azure Stack HCI, which gets billed to your subscription in Azure. Security is where we'll see many of the Azure Arc is where you'll see that a bit of that integration. There's not too much there right now from this perspective. If we go over to security, we'll see some of those secured core components that we were talking about. The updates are a big part that everyone always wants to see. Takes a little while to load, but once it does, it's pretty simple, right? So once we start the cluster, we'll come over to this updates tab. It'll ask us, hey, I see you don't have a role installed on these servers. Would you like me to go ahead and install that role? It's a one click. It deploys the role to all the nodes in the cluster. It checks for updates, and you'll see we have a few here once it finds them. And this cluster aware update role is very important because it basically allows you to one click upgrade the nodes in the cluster. This cluster update role is aware of where VMs are in the cluster. And so, say, for example, we need to install these updates. We can install, and it'll take one node down gracefully. First, it'll move the VMs to other nodes in the cluster. It'll set that host into maintenance mode. It'll take down the host for updates. It'll bring that host back up, ensure that it all looks good, take it out of maintenance mode, and then shift the workloads back over to it automatically before going over to the next node. So that's how the updates will look. Our virtual machines are going to show the VMs which are currently running on our cluster. So for example, we have 2 VMs right now, our server 2022 core, and then our Azure Stack VM02. If we click on to that guy, you see you have all your basic settings that you would typically expect out of a hypervisor manager, things like connect. So it gives you quick access to an RDP file, or we can do a console, which I'll bring up in just a second. We can change the power status of the cluster or of the VM by, we could also save the state of it, pause it, reset it, all those things that you would normally expect. We can move it, so a live migration. We can move to different storage vMotion, for example, is also available. You can clone it. Say, for example, you have developers who are needing to test updates, clone your VM, deploy it into an isolated virtualized network, and test their updates. And then once they feel confident, tear down that clone and then actually do the production update. We can also rename. We can create a checkpoint here. You can see there's even a button which is currently grayed out for Azure migration. So for example, maybe you don't need to have your VM running on premise. You can eventually access for the Azure migration component. You can also domain join from that screen, right? That's an important piece, right? We don't want to necessarily have people logging into all these VMs and these core OSs. So being able to do some of these simple operations without necessarily needing to go into the VM is a big part of what the Windows Admin Center is actually designed to do. And here you can see just some of the general settings which you would expect. Things like memory. We have dynamic memory utilization. This is a Windows 11 VM. So we also have processor configurations. We're not working on sockets. We're not working on cores. It's just a number of virtual processors now. Your disk, this is where you'll set up your ISOs, right? So If you need to boot into an ISO to install a VM, this is where you can add that. You can configure your networks in here, the boot order, checkpoints, regular checkpoints, affinity rules, so the security of the device, and then those integration services, which we were talking about with Azure Backup and those features. The console itself looks like this, and all things considered, I'd say it's a pretty good console. The idea is that you shouldn't have to console into the VM at any point, but if you need to, you can come up here, connect. It'll ask you for your password. And because this one's not joined on the domain, it asked me for a second password. And there we have our Windows VM. There are some advanced console capabilities, so things that you may not have today, like copy and pasting text into and out of a console, is available. That's really nice. This is a little disk performance test, right? You can see we were getting 5 gigabyte a second on reads. That's thanks to those high performance cache drives we were talking about. And that's kind of what the console looks like. The server view shows us all our servers that are in the cluster. Right now, this is a 2-node cluster, and here you can see the uptime, the manufacturer, the model, the serial number, the memory usage, what OS it is, etc. If you needed to add another node to the cluster, you basically install the OS, ensure that the OS is available over the network using sconfig, and then you come in here, add it, and it'll automatically go out to that node. It'll install all the necessary roles and features, and it'll assimilate that node into the cluster for you, which is really nice. Our volumes are going to be logical isolations of ways that we want to separate our storage. So in here, you can see I have a little spot for Azure Kubernetes systems, high performance history storage of the performance. This is where I like to store cluster VMs, and then finally an ISO location. This is one way to look at it, and what's kind of cool is you can just dive into each one, and you can actually open them from here as well. Say, for example, you don't necessarily want to have to log into that. You can use Windows Explorer just as you normally would, right? We just RDP, or we type in a network location, in this case, one of those nodes. We hit the $, which is where our cluster storage mount point is. And you can see all the same volumes which were available there are also available here. So you can click and drag and delete and manage the data within these volumes using, again, familiar methods. If you don't want to, you can stay completely in this interface as well, which actually transitioned over to the node itself, which is a good time to actually show you as well, right? So now we're not looking necessarily at a cluster view. This is the node view itself. So not having to manage, again, the OS by logging into it by console. This is a really nice Windows Admin Center feature where you can do most of the stuff you would want to do just through the Windows Admin Center, right? You can view the event log. You can do files and file sharing, things like making sure that your shares are up. You can add local users and groups. You can list the installed apps. You can manage the Windows firewall, Windows Defender for the cloud. We can go through the registry. We can access PowerShell from here as well. Do packet monitoring, look at the networks that it's connected to. We could view the services, stop and start services, and we can even run updates from here. The idea, again, is that you shouldn't be logging into VMs anymore. Remote management is the way that this is trying to go. So back to the cluster view. I think I made through most of it, but you'll see also as well here, we have our drives. You can see they're just, if you want to view the inventory of the drives, here we have the ability to turn the lights on if that's a capability of those drives. In this case, it's not. We can retire them, take them down, or even bring them out of retirement. Lazy drives, if we need to re-enable them. Here, again, we can see we have Azure Kubernetes service, which we're deeply integrating with Azure Kubernetes. The idea is that you you are just able to simply run these Kubernetes clusters on the OS, and it helps manage them for you. Automatically scaling is needed, and then deploying new instances as required. GPUs are a big part of Azure HCI. As machine learning becomes more prevalent, as people need access to higher graphically intense applications, we have the ability to utilize GPUs and assign them and share them to different VMs within the cluster. Network intents, like we were talking about before, these intents are all listed here. And you can see the network adapters which we're using, and then the performance monitor, which I talked about on the performance slide, event viewer. And here's SCVMM. If you haven't used this before, it's basically a hard application which is enabled for managing those VMs. So again, back to the vCenter 5.0 days when we had a physical client, Azure Stack HCI has a version of a physical client which can manage the cluster itself and also VMware clusters as well. This one is a VMware cluster. This one is our Azure Stack cluster. So similar to what you would expect in a virtualization-based client, you can create new VMs, clone them, reset it, save the state, store in a library, migrate the virtual machine elsewhere, checkpoints, connect or view, connect via console, right? All those typical things that you would expect out of your virtualization management client. And you can see we're also using enhanced session here. So we're able to copy and paste information out of this console because we allow it. That is kind of a general overview of how you would manage the Azure Stack HCI. Again, if anything, go download the Windows Admin Center, start to get familiar with it. It's again, a free tool. It can be run locally or on your system, or it can be run on a shared system. I have it deployed on a shared system just because I like to make sure that everybody's kind of utilizing that one location. It's centralized, and in the event we need it, we can run it locally.
Awesome. Thank you, Brad.
Thank you.
So running a little over, but we'll get through the additional thoughts and recommendations. So having heard everything here and getting kind of our sentiments and how we've approached Azure Stack HCI and our understanding, we feel like the promise of an on-prem region, right, where you're able to run Azure workloads locally is appealing to lots of folks. Obviously, there's a lot in the landscape around hypervisors in general and looking at alternatives, et cetera. So with that, we think that Azure Stack HCI is something that IT consumers should pay pretty close attention to. It's got a lot of promise. 22 H2, we feel like it's pretty viable, stable, been out on the market for a while. It's a fairly well-known entity, worth looking into and putting trust in its reception in the market. 2023 H2 is kind of, even though it's been out since November, it introduced significant changes in the way that it was deployed and managed. So we have seen some challenges around that. We like the idea of where it's going to. Wish it would get there a little faster, to be candid. So for that one, we really recommend piloting its use and kind of looking at the adaptability based on your workload, your IT team's ability to react to those rapid changes. And we do also expect, again, the theme of this is kind of the rapid evolution and lots of changes. So we expect that to increase in pace as Microsoft responds to customer demand and interest in the product. And as far as resources, most of you are probably familiar with Microsoft Learn. Certainly Azure Stack HCI is well covered within Microsoft Learn. So just about anything and everything that you'd want to know about Azure Stack HCI is available there. It can be a little bit of a loose reading, right, with bits of information scattered around as you look to find it, as those of you probably know Microsoft Learn are familiar with. There is also a foundations training that kind of is a piloted course where that's going to give you kind of the intro and overview, as well as some kind of experience with the management and the deployment aspects of Azure Stack HCI. So that one's highly recommended. And as mentioned previously, keeping up with changes, release notes are the best place to find that. Any sort of announcement, changes, things in the future even will be kind of footnoted out in release notes. And from our team, certainly Prescriptive would very much like to talk to anybody that would like to talk about Azure Stack HCI. There's certainly a lot of folks within our existing customer base that were having those conversations today, and you can coordinate that through any of the three of us with our contact there on the slide. So either Rowdy, Brad, or myself. And thank you so much, everybody, for joining us today. Appreciate your time.
Thank you, guys. We will be sending out a copy of the slides to everybody who did attend, and we hope you all have a great rest of your day.